Alexa, let's chat. Hi, my name is Gino Choi. I'm an assistant professor of computer science, QTM, and linguistics. In this short video, I'll show you the exciting journey that we went through to win the Alexa Prize Socialbot Grand Challenge. That is a university competition to develop the next generation chatbot that can be part of your life in the near future. Excited? Let us begin. The next two videos demonstrate the limitations of the current state-of-the-art chatbots. These videos are featured by me and my two PhD students, James and Sarah Finch. Enjoy!
Hi, this is an Alexa Prize Socialbot. I don't think we have been properly introduced. What's your name, my friend?
Bob.
Hey, Bob. I'm happy to meet you. I'm not sure if we've talked before, have we?
No.
Really? That's great. Let's get to know each other. How is it going?
I just bought a big house.
No! Bob, I'm sorry to hear that. I hope everything will be okay soon. What would you like to talk about? Let's say celebrity, games or fashion, or anything else?
I just bought a big house. I should be happy.
Bob, let me ask you. What's your favorite sense? Touch, sight, taste,
Alexa,
smell,
stop.
or hear?
It is clear that the bot had no common sense to understand the meaning of buying a big house, which can be a lifetime achievement for many people. So the proper thing to say was, congratulations. Let's take a look at the next one, shall we?
Hi, this is an Alexa Prize Socialbot. It's really good to meet you. Do you want to tell me your name?
Mike.
Hi, Mike. How are you doing today?
My grandma just died.
Oh, I'm sorry to hear that. Hopefully chatting with me will make you feel better. So, I'm a huge movie fan. Do you like to watch movies?
My grandma just died. I don't want to watch movie.
Ooh, I'm excited to talk about movies. So, have you seen any movies lately?
Alexa, stop. So this time, the bot did understood the sentiment of my grandma being dead. So it did say the proper thing, I'm sorry. Then what did it say? Let's talk about movies. What kind of human being will ever talk about movies after hearing your friend's grandma just died? Unfortunately, this is the current state of the chatbot. And we are trying to do better through Emora development. Then, who is Emora? Let's find this out. Emora is a conversational AI-based chatbot that we have developed for the last 2 years. When people think about a chatbot, they often think a personal assistant or someone who can help for customer service. And people often use chatbot as a search engine. And if you have a large home, you may want to use it as a smart controller. But what we want to develop is a chatbot that can be your social companion. So by the end of the day, we want Emora to be someone who will be there to listen to you, share thoughts and feelings and experience with you, so you can have a deep conversation with it in a very personal level. Then, how do we meet Emora? If you have an Amazon Echo device or install an Alexa app on your mobile phone, you can talk to these chatbots by saying, Alexa, let's chat. Then, one of the 9 bots participating this year's Alexa Prize will be randomly selected. But Emora remembers everyone she talks to. So, if you're lucky, you may get to talk to Emora again, then she will greet you back with a happy face. Want to know more about Emora? Let me explain little technical details about Emora. Don't go away, it's not gonna be boring, I promise. When the user interacts with the Alexa app or Echo device, their voice goes into an automatic speech recognizer, which transcribes the voice into text. This text gets into so many NLP models that we have internally developed to generate what we call a concept graph. This concept graph feeds into our another model that does probabilistic reasoning. This makes logical inference to find out what is the most appropriate thing to say the next. And these logical forms get into a deep learning model to convert those into a text to say back to the user. All these states are communicating via State Manager. That is a large database that saves all information that has happened during the entire conversation. Currently, all these development are done on AWS, which is the cloud computing service provided by Amazon. Let me explain the technical challenge we often experience for the speech recognizer. So when user says something such as who is Barack Obama, the speech recognizer usually does a very good job. So as you can see here, every word here has a very high confidence, and its overall confidence is close to 90%. However, if we say something like, who is Gino Choi, my name? The confidence level goes so much down. So if you actually try to look what's happening here, instead of recognizing Gino Choi, is recognizing something like Jin Hota Hai with a very low confidence, and the overall confidence level is even 0. So the biggest challenge right here is obviously this speech recognizer is not familiar with my name, so it will not produce the name that I desire. It's very sad because the bot that I developed does not recognize my name, but I just have to bear with it. And this is a reason why I had to use the name like Bob and Mike in the previous demonstration. Finding something interesting? Things are about to be spicier, so stay tuned. Now that we understand how speech recognition works, let us move on to the most exciting part, the concept graph. The concept graph is how Emora represents world knowledge and concepts in her brain. And we are practically using every single NLP technique that we have developed, which has been released through another project called Elite, to generate this concept graph. Are we ready to explore what's going on inside of Emora's brain? Let's go. Let me demonstrate how a concept graph can be generated given a sentence like, my wife rented The Lion King and watched it with Sam yesterday. The first, we segment every word into tokens, then run a lemmatizer to find root form of every word. Also, we run a power of speech tagger to find a grammatical category of every word too. So given this, now we can generate a concept per token. There are mainly two types of concepts. One is a constant and the other is a predicate. A predicate can take an argument as constant or a predicate as well. And there are also some time information that can be inferred from the power of speech tags. There are specialized predicates such as possessive, and also there are specialized constant such as and, which refers to a grouping information. And also, there is a specialized referential information. Given all these concepts generated from the tokens, then we further run name entity recognizer, which recognizes Sam as a person, so we introduce a new concept to this segment. Then we run some gazetteer matching, so we can actually match the movie titles, book titles, any kind of these titles. Once we run gazetteer matching, the new concept can be generated as a movie name. Then we run a dependency parser, which gives a complete structure of every relation of the words. And from this, we can even infer Lion King is a compound noun that can be introduced as a concept. We further run a semantic parser to find even richer relationships. So given this, we actually can infer another time information such as yesterday that can be attached to two separate predicates called rented and watched. So there are also specialized predicates such as my. So my can mean possessive or some relationship. So when I say my wife, I don't possess my wife, but I am having a relationship with my wife. So there can be an alternative predicate that can be generated as a concept here too. On top of this, we also run coreference resolution, which connects concepts across different utterances as well. And also emotion detection. We're not done yet. Given all these concepts, we do the ontology matching, so we know what type of those concepts are. And this ontology doesn't stop in this one level. It actually goes all the way up to the very high level to the entity and event. Finally, we start doing concept trimming. So let me show you. So given our word my, we actually introduce two potential concepts. One is possessive relationship and the other is a wife relationship. And we try to infer what kind of relationship in this case should be appropriate. And the argument y can be filled with the instance C2, which refers to the wife. So in this case, we have only left with the wife relation. Now, the Lion King, now there are potentially three different concepts, groups of concepts that can represent the Lion King. So the very top one is a token level, and the bottom one, the left bottom one is the movie title, and the another one is unknown type. So in this case, it's pretty easy because the movie title was actually very clear, whereas the unknown or token level, the concepts are more or less ambiguous. So we retain only the one with a movie title. Also, the grouping information is actually very useful for different constant concepts. But in this case, for the predicates, we already have resolved all the arguments, so the grouping is not so much important. Now, there are two concepts representing Sam, and this is also another easy case. The concept generated from a token is actually unknown, whereas the concept generated from the name entity recognizer is clearly indicating Sam is a person, so we retain only that concept. At this point, we have trimmed out all the concepts, so only the unique concepts stay. Given this, now we can, using all the dependency relationship and semantic parsing relationship, we can actually develop what we call a concept graph. So the concept graph is showing the relationship between every possible concept that has spoken. And this is, I'm showing only for one sentence, but this gets accumulated across the entire dialogue. So you can actually run a complicated logical inference on top of this. Wow, that was intense. But important thing is you stayed with me. There are two other stages, probabilistic reasoning and response generation, that I didn't explain in this video. So feel free to email me if you have any question. As you can see, Emora is great. But how is she doing in Alexa Prize this year? She is the defending champion. Is she going to win again? Thumbs up if you think so. Last year, there were 10 teams participating into the Alexa Prize. And Emory University won the first place with a final score of 3.81. which was the groundbreaking score in the history of Alexa Prize. This year, there were 5 returning teams and also 4 additional teams. We are currently in the stage of the quarterfinals. Do you want to know how Emora is doing? Here you go. So these are the scores that has happened for the past 1 month. And here is Emora. As you can see, we're not doing bad. So we're hopeful that we will shock the world once again. That's it for today. Thanks for listening. I'm so proud that I'm a faculty member of Emory University. One last thing. Remember, Emora cares for you. Bye!